So let's graph this conic section. First of all, they'll ask what graph does it represent, and you can tell right away that the graph, because the leading coefficients are opposites of each other, this is a what?
Parabola?
Nope.
No.
It's not a parabola because there's squared. Yeah. Both of them are squared. Since both of them are squared and the signs are opposites of each other.
Oh, right.
It's got to be
hyperbola.
A hyperbola, right. So this is a hyperbola, and the step that I'm going to take now is to complete the square. So I'm going to take the x's, separate them out. I'll do those in red. I'll leave a little space there. I'll take the y's, separate those out. I'll do that in blue. So minus 9y squared plus 54y. I'll leave something there. Equals, I'm going to move the 47 over to the right side. So I added 47. Now I'm going to add something and subtract something to both sides. So whatever I add here, I'm sorry, not subtract. Whatever I add, I also have to add to the right side. And it's half of that squared. So it's 25. And I do that because now when I factor this, it's going to be x plus 5 quantity squared, because x plus 5 times x plus 5 equals x squared plus 5x plus 5x plus 25, and 5x and 5x is 10x, and that's how I got that. So I did that purposely. I added 25 there purposely because I knew that adding a 25 right here would give me the right expression to be able to complete the square. That's why it's called completing the square. So if I add it to one side, as always in math, I have to keep balance. I have to add it to the other side. Now this is a little bit trickier. The y one's a little bit trickier because I've got a negative 9. So the trick with this is to factor out that leading coefficient. So it's going to be y squared minus 6y plus, now I'm going to take half of this and square it. So that's not 3 squared is 9, or negative 3 squared is 9. But now I didn't just add a 9 to this side. In fact, I didn't add a 9 at all. I subtracted a negative 9 times 9, which is 81. So I'm really subtracting 81 from both sides. See what I did there? So because that right there was really what I added to that, what I included to that side was subtracting 81.
That's what I was doing wrong.
Yep.
I was not subtracting, I was adding.
There's your difference.
Mm-hmm.
There's where you made the mistake. All right. So whoops, that's not a x, that's a y. So it's going to be y minus 3 squared equals, add those up. So that's 9 over here. When you add these things together, you're going to get 9. You're going to get x plus 5 squared minus 9 times y minus 3 squared equals 9. And then they teach you to divide both sides by 9. So divide all the terms by 9, and you're going to get x plus 5 squared over 9 minus y minus 3 squared equals 1. And so you can see that these numbers right here, that number, and there's a 1 underneath there, those numbers are the radiuses, those help you determine how to draw your hyperbola. So let's start on a new page here. What I'm going to have is since the x is positive, since the x term is positive, the parabola is opening in the x direction, so it's going to open like that. And let's go ahead and find what the center is going to be. It's going to be negative 5. Remember, you take these things out right here. It's going to be negative 5 and positive 3. So that point right there is negative 5, positive 3. I'll draw the axes in later when I figure out where everything's at. The x distance right here, the square root of this tells you the distance between that 3 right here. The square root of 9 is 3. That tells you the distance right here. That distance is 3. So if this point is negative 5, 3, then that point right there is -8, 3, and that point right there is, what's it going to be?
-2, 3.
-2, 3, good. So that's that. Now, the fact that, I'll change colors here, I have a 1 underneath here, the square root of 1 is 1. That tells you how high up your box is going to go, because what you'll ultimately do is you'll draw a box in like this, where this distance is 1, that distance is 1, this distance is 3, that distance is 3. So this is a 2 by 6 box. And that we do that because that shows us, I actually need to maybe erase this. That box shows you, if you draw diagonals through that box, those are the asymptotes for your hyperbola. So that's what I've got there, and then this point right there, it goes like that, there, and there. And so the equation of those asymptotes, you can write the equation of those lines right there by using point-slope form. The point is -5, 3, so it's y minus 3 equals the slope, which is up 1 over 3, 1/3, and it's going to be plus or minus 1/3 because you're going in both directions. See how the slopes are? Both, and one's a positive, one's a negative, times x plus 5. So it's really not a hard equation to write if you remember your algebra and how you did that with algebra. So there's your equations of your asymptotes. They'll ask for that a lot of times. The blue is the graph itself. The green right here are the vertices of the graph right here. Those are your vertices of your hyperbola, and the center is right there, -5, 3. That's how you graph that parabola or hyperbola.